The next one, show that the ratio of the sum of first n terms of a GP to the sum of terms from n plus 1 to 2nth term is 1 by r raised to n. So we need to show that ratio of the sum is 1 by r raised to n. Ratio of sum of first n terms, that means it is Sn, by sum of terms from n plus 1 to 2n. So first we will calculate Sn and the second sum. Okay, the first one is Sn. It's a GP. So the formula is A into r raised to n minus 1 by r minus 1. So let this be equation number 1. This is the first sum we require. The second sum is we have to find the sum of terms from n plus 1 to 2n. So we have to find a sum so that the term is from n plus 1 to 2n. n plus 1th term will be a into r raised to n. Why you know? Nth term, how we are saying nth term? Nth term is a into r raised to n minus 1. So n plus 1th term will be a r raised to n plus the next term will be a r raised to n plus 1 plus next term will be a r raised to n plus 2 plus etc. The last is the 2nth term. That will be equal to a into r raised to 2n minus 1. Okay, so how many terms are there? Can you guess? n plus 1, n plus 2, n plus 3 etc. 2n minus 1. And there is an a into r raised to n. To find the number of terms, what we have to do is, number of terms will be equal to the last power 2n minus 1 minus n plus 1. Difference between these two powers and add 1. So what we get is 2n minus n gives you the value n, minus 1 plus 1 gives you 0. So number of terms in this sum is n. So there are n terms starting from a r raised to n and ending with the a r raised to 2n minus 1. So what we will do is we will consider the term a r raised to n, a r raised to n plus 1, a r raised to n plus 2 etc. It is a GP. Okay, is a GP with the first term a r raised to n and a common ratio a r raised to n into r gives you a r raised to n plus 1. Common ratio r. So what we require is sum of the GP with the first term a r raised to n and a common ratio r. How many terms are there? N terms. So instead of this writing like these terms, it is just enough to calculate the sum using the formula to find sum of n terms of a GP, provided first term is a r raised to n and common ratio is r. So here also the formula we will apply the same, a into r raised to n minus 1 by 1 r minus 1. So here the first term is a r raised to n. So a into r raised to n, r common ratio is r itself, minus 1 by r minus 1. Let this be equation number 2. This is equation number 1. What we require is the ratio of this sum to this one. So we will take the required ratio. Required ratio is equal to ratio of sum to n terms. N terms is a into r raised to n minus 1 by r minus 1 is to sum of terms from a r raised to n to a r raised to 2n minus 1. That is n plus 1th term to 2nth term. N plus 1th term is a r raised to n and 2nth term is a r raised to 2n minus 1. And the sum means a r raised to n plus etc. a r raised to n minus 1. So we are considering these terms as a GP, and there are n terms with the first term a r raised to n and a common ratio r. So we got the sum of this value as a r raised to n into r raised to n minus 1 by r minus 1. So second ratio is a r raised to n into r raised to n minus 1 by r minus 1. What happens? A gets cancelled. Okay, r raised to n minus 1 gets cancelled. R minus 1 gets cancelled. What is the balance? 1 is the balance in the first ratio, is to r raised to n in the second ratio. So required ratio we can write as 1 is to r raised to n, otherwise 1 by r raised to n. This was what we had to prove. Okay, the only thing is you have to consider this as actually it is a GP, don't combine it with the first n terms. Starting with the n plus 1th term, it's again a GP with the first term a r raised to n and a common ratio r. So we will calculate the sum using the same formula to find the sum of the GP a into r raised to n minus 1 by r minus 1 and take the ratio. So we will cancel all the term, giving you 1 in the first ratio and r raised to n in the second ratio, and we are getting the required ratio as 1 by r raised to n.